Welcome intellectuals. So we're going to finish where we ended. We ended on this question. I'm going now to, I was just at the conclusion of this question now. In case somebody may start from this video, it won't make sense if I just start from the end of this question. So I'm just going to start from the beginning. So the question reads, imagine that on your wedding day, your lover gives you a gold ring of mass 3.80 grams. 50 years later, its mass is found to be 3.35 grams. On the average, how many atoms were abraded or weared off from the ring during which heat second of your marriage? Okay, the atomic mass of the gold is given as a 197 mass unit number. Okay, where one unit mass number is equal to 1.661 times 10 to the power negative 27 kilograms. Okay, I'm not even going to be fast. I'll just be moving as slow like the way I was moving here. So what we have been given, guys, we have been given our mass 1, our M1 to be 3.80 grams. Okay, so after 50 years, the mass was reduced to 3.35 grams. This is what you need to notice. Okay, so we have been also given the period, guys, of 50 years. You shouldn't forget. It is also important to take note of this. What else have we been given? We have been given the atomic mass of gold. Okay, the atomic mass of gold to be 197. Okay, mass unit number there. What else have we been given? We have been given to say what? One mass unit number is given by 1.661 times 10 to the power negative 27 kg there. Okay, so what are you going to do next? Since we have corrected all the data, let's go ahead now. Our first thing, we're going to find the mass which was lost, because we have seen a difference in mass. There is a drop. So we're going to find the mass which was lost. So guys, follow all the steps like the way I will be showing here. Okay, so the mass which was lost is going to be found by M1 minus M2, where our M1, guys, is 3.80 minus 3.35 grams there. Okay, so our answer for the mass which was lost is going to be 0.45 grams, which we are going to convert in kilograms to be 0.45. That we multiply by 10 to the power negative 3. That's how we convert grams to what? To kilograms. This is the mass which was lost. This is just the beginning of the question. We are still moving. Okay. What is the mass now of one gold atom? Okay. We have been given to say, let's go ahead, our step 2, the mass of one gold atom. Okay, here is what we are going to do. We have been given, the atomic mass and what? The mass of one mass unit number of what? Of an atom. So to find the mass of one gold atom, we are going to multiply the 2. Okay, we're going to multiply the 2. So our mass of an atom is going to be given by 197 there, multiplied by 1.661 times 10 to the power negative 27 there, kg. What is our answer we are going to get? We are going to get 3.272 then 17 times 10 to the power negative 25. Negative 25 kg. So this is the mass of a single what? Of a single atom. So let's go ahead now. Since we have the mass of a single atom, let's find the number of atoms which were lost. Just follow the same steps like the way I'm giving out the steps, guys. Okay, so now to find the mass, the number of atoms which were lost. Okay, the number of atoms lost. Okay, the number of atoms lost here is what you are going to do. We know the mass of the mass of the atoms which were lost. We already know. We found this is what we found in the first place. We are going to divide by the mass of an atom here, which you are just from finding. So here's what you are going to do now. So our n is going to be the mass which was lost was 0.45, guys, times 10 to the power negative 3 kg. Okay, what about the mass of an atom? The mass of an atom is 3.2721 times 10 to the power negative 25 kg there, where kg and kg will cancel. So the number of atoms which were lost, okay, the number of atoms which were lost now becomes to be 1.337523, then times 10 to the power 21. This is the number of atoms which were lost. Okay, we are still moving. Now we want to know now the number of atoms which were lost per second. This is how the question is asking us to do. Okay, so to find the number of atoms which were lost per second, here is what we do now. Okay, since I don't have a space, let me just try to reduce my font here. So what we are going to do next, we are going to convert first our 50 years into seconds. Okay, so here is what you do. We are using dimension analysis as usual. We're going to say 50 years multiplied by, to cancel years, you have to put years on top here. We are going to say 1 year is equivalent to 365 days if we integrate leap years. Okay, now to cancel days, now we are going to put days there down. 1 day is made of 24 hours. This is what I was doing. Okay, to cancel also hours, what we want is to remain with seconds. To cancel hours, we're going to say 1 hour is equal to 360 minutes. Guys, what about the 360 minutes? Okay, what about 1 minute? 1 minute, here we say 1 hour, here we have 1 day, here we have 1 year. 1 minute now, 1 minute is equal to 60 seconds. So here is what we are going to do. We are going to cancel now. We are going to cancel this. As you can see now, minutes and minutes will cancel, hour and hour will cancel, days and days will cancel, years and years are going to cancel. This is the interesting part about dimensional analysis. So what have we remained with? We have remained with 50 multiplied by 365 multiplied by 24, then we multiply by 30. Here it is 60. 1 hour is made of 60. Okay, it is 60, then multiply by 60 seconds there. So we've remained with seconds there. Okay, so our answer now is going to be, once you punch that on your calculator, what are you going to get? We are getting 1.5. Okay, 1.5768 times 10 to the power 9 seconds. this is what the how we can convert 50 years now into seconds. What we need to know, the question is asking us to find the number of atoms which were lost per second. Already we found the number of atoms which were lost, okay? And the time in seconds. So to find the number of atoms which were lost per second, what you are going to do, guys, we are going now to divide this, okay? We divide this into this. Because I don't have enough space, go ahead and divide this into this, okay? Once you divide this, you are going to get 1.37523 times 10 to the power 21 divided by 1.5768 times 10 to the power 8. You are going to get 8.72 times 10 to the power 11, which is atoms, which were lost per second. Okay, this is how simple. This is how simple you do this kind of a question. It is very okay. Let's go ahead now and do this question. What question have we remained with? This is the question I will remained with. Okay. So just some minutes. I'm recording the video. I'm sorry for the disturbance. Okay. So here is what you are going to do. We are adding this. Okay. We are adding 21.4 plus here we apply the information of significant figures. Okay. So there is also 16 there. I mean 15. So once you add this, you are going to get the answer like 57. My calculator is giving me 57 and 573 there. So how are we going to determine the answer? We are going to look at 15. It is the one which has smallest significant numbers there, okay, which has just 2. And at the same time, it has no decimal number. So our answer is going to remain with 2 significant figures with no decimal number. So we're going to stand at A. Since 5 is greater or equal to 5, we're going to add 1 here. We're going to have 58. Guys, you need to be serious with these simple things. They are very important. You may be assessed about that. Okay? Let's do another question, which is also very important. This is now on order of magnitude and estimation. So on 10th December 2018, Dr. Kahunda would be 94 years to 52 days old. Find the order of magnitude of Dr. Kahunda's age in seconds. Okay. The head of our Dr. Kahunda has been given to be 94 years, then 252 days. Okay. So for us to add well, guys, for us to add well, we need first to convert years into days. Okay, so we're going to convert years into days. How do we convert years into days? We are going to multiply. So we're going to say our total years, our total days, okay, our total days are going to be, to convert 94 into days, we are going to have 94 times 365, since 1 year is equivalent to 365 if we ignore the leap years. Then we are adding these 252 days there. So what we are going to find is the total days. So the total days of our Dr. Kaunda now is going to be 34,000, okay, 34,464. 34,462 there. 62 days. Let's go ahead now and convert this in seconds, because you have been asked to find the order of magnitude in a second. Here's how simple you go about it. As usual, we are using dimensional analysis, so I'm going to say 34,462 days. Okay, we multiply by, we take day there. Okay, we take day there, and one day is made of 24 hours. Okay, now to cancel hours, we put 1 hour here, and we say 1 hour is made of 60 minutes. To get rid of minutes, we say 1 minute is made of 60 seconds. So we can now tell to say days and days will cancel, hour and hour will cancel, and minutes are going to cancel. So what we have remained on top is to multiply 34,462 times 24 times 60, then times 60 there. Okay, so our answer now we are going to get will be in seconds. Okay, since we have remained with the seconds here, so our answer is actually going to be 1.57. Okay, it's going to be not, it's not 1.57, it's going to be 2.9. Okay, 2.9775 168 times 10 to the power 9. Okay, so if you were asked to convert this aid in a second, you would have ended here. Now that the question is to find the order of magnitude, guys, the order of magnitude is just the power of 10. Okay, so the answer which we found, we convert into scientific notation, and we take the power of 10. So this answer is already in scientific notation, so we're going to get this 10.9 as our order of magnitude. As simple as that. Okay, let's go ahead and do this interesting question. Okay, it is one of interesting questions which you need to know about uncertainty in measurements. Okay, in an experiment, a radio controlled car takes 2.5, okay, 2.50 positive or minus 0.05 seconds. So you can even say that this is for time, and it to travel. What did this radio controlled car covered? So the car covered 40.0 positive or minus 0.1 meters. Okay, what is the car's average speed and the uncertainty in measurements? Okay, like I'm saying, guys, uncertainty is just the error that that may occur in every measurement, because we need to know that not all measurements are accurate. You can make mistakes whenever you are taking measurements. So since this is time, because of second, this is time, this part is going to be our time. Okay, and this is going to be our error, and it is noted by delta t. Okay, so this is our distance now, the distance which was covered, okay, which you are going to call x in this case, x, and this is our uncertainty, is going to be delta x. As simple as this. So let's go ahead now and find first the speed. We have been asked to find the speed. The speed v is going to be distance over time. We are going to take our x is 40, and our time is 2.50. Once you divide this on your calculator, you're going to get 16.0 meters per second. That's why you are seeing 16 everywhere on these options. So our trick part now is to go ahead and find the uncertainty in measurements. The uncertainty in measurement for the average speed is going to be given by delta v over v, also delta t over t, plus delta x over x. As simple as that. So our delta v, guys, now is going to be, because our v we already found to be 16 there, our delta t is 2.50 and our time, sorry, our delta t is actually 0.05. So it is, let me just cancel it instead of I waste time erasing, 0.05 over 2.50. now we had we go ahead and we had by 0.1 over 40. Okay, so what we are going to have next is our delta v over 16 to be equal to this into this. We are going to get 0.02. Okay, we are going to get 0.02, and this into this we are going to get 0.0025. Okay, let me finish my work here because I still have a small space here. Okay, so here is what we are going to do. This plus this, okay, delta v over 16 is going out to be equal to 0.0225 there. Okay, so now you can cross multiply. We're going to have our delta v to be equal to 16 multiplied by 0.0225. So that's why our delta v now is going to be 0.36. So you can even tell to say, since our first answer was this 16 and our delta v is 0.36, so that means according to the options which have been given, option D is the correct answer. Let's do question the following question. Okay, the following question now is to go ahead and estimate the number of cells in the human brain. Like I was telling you in the first place, when it comes to estimation, what you do, you need to make the reasonable assumptions. We don't just dream of the assumptions which we are going to make. Okay, so our first thing is to find the volume of the brain. Okay, we're going to estimate the volume of a brain here. The volume already, we from dimensional analysis, we know that volume is L squared there. Okay, this board is only suitable for white car. Okay, let's now estimate the length. Okay, the length of the, because the body, you know that the brain occupies the largest part of the what of the body. So I'm going to estimate to say that it will occupy the upper length of the head to be of 0.2 meters. This is what also for the length that a brain can occupy in a whole human head. This is the reasonable thing you need to know. So what you are going to do now is just to find the volume of a brain to be now 0.2 to the power 3, which is going to be our 8 times 10 to the power 3 there. Okay, it is nice here to say that we are doing estimations. So what we are going to do now, what we are going to do is this. We are going to do this. Here is what we are going to do. Okay, we are going to stand at this point. Okay, so no one should be confused. Okay, no one should be confused because this number is very close to 10, because we know that this number, when we say that the scientific notation are in form of 10 m times 10 to the power n, where m should be less than 10. So this number is very close to 10. Okay, it is same as we can write this as 10 times 10 to the power, here we have negative 3. Of course it is negative 3 there. Okay, writing this is same as writing as 1 times 10 now since we have 10 here and this 10, it's like we are adding the power, so we are going to have negative 2. I explained this in the previous video. So this is now to be our volume. Okay, this is now going to be our volume of the brain, as simple as that. Since now we have the volume of the brain, let's go ahead and estimate the volume of a single cell. Okay, the volume of a single cell also is going to be given by distance squared. Okay, from what you know, okay, from what has been already given as the reasonable assumption I was given, the volume, the distance of or the length of a single cell is approximately, and it is typically known to be, so our d is going to be 1 times 10 to the power negative 15. Okay, let me say 1 times 10 to the power negative 16 there. Okay, this is what you need to know. This is what you need to know. What are we going to do now? We are going to square this. Okay, sorry, here we must have cube there. So here is what we do next. We are going to, since this is our distance, which we assumed to be the length of a cell, of a single cell, what we are going to do is now 1 times 10 to the power negative 6 raised to the power 3. So our volume of a single cell now, excuse me for the pop-up messages there. So when you multiply out this, you are going to get 1 times 10 to the power negative 15 cubic meters. How are you going out to find the number of cells? Since we have the volume of a cell and the volume of a brain here, where is it? It is here. I want to see where the brain of the cell is. Something somewhere 10. Okay, it is here. It is here. So what we are going to do now, we are going to say the number of cells is going to be the volume of the brain. We divide by the volume of a cell. So we're going to divide the volume of a brain is this, we divide by this. So our answer is going to be 1 times 10 to the power 13 cells. You should know this kind of equation. Okay, so estimations and approximation sometimes seems to be difficult. So what you need to know, guys, at least you know the typical assumption, that reasonable assumption which is acceptable. You need to know that. Like there's another question which you are going to do very soon. Okay, now let's do this question. Okay, this is coming from tutorial sheet 1. Treat a cell in a human as a sphere of radius 1 micrometer there. Determine the volume of a cell. 2. Estimate the volume of your body. And C. Estimate the number of cells in your body. So here is how you go about it. The radius has been given to be 1.0 micrometers there. So to convert this into meters, because micro is a prefix which is treated as 10 to the power negative 6. So to convert into meters, we are going to say 1.0 times 10 to the power negative 6 meters. Okay, because we need to use the standard units there. So now, to determine the volume of a cell, we have been told to treat the cell as a sphere. So the volume of a cell is the volume of a sphere is given by 4/3 multiplied by pi r cubed there. We used this formula before. No one can get confused. By R, and our R is this. Okay? So finding the volume of a cell now, we are going to have the volume of a cell to be 4.19 times 10 to the power negative 18 cubic meters as that. Now let's go ahead and estimate the volume of your body. How can you estimate the volume of your body? This is actually what I was talking about here. You're going to make an assumption. I don't know your body, but so what we do here, we answer in general. Okay, the mass of the body of an adult is typically to be 70 kg. Okay, and the density now, because to find the volume of your body, you are going to use the formula for density, which is mass over volume. So now the density, we are going to use the density of water because we know that the water occupies the largest part of your body. So I'm going to use the density of water. Let's assume the density now is approximately to 1000 here, to 1000 kg per cubic meters there. Okay, so now let's go ahead and find the formula for mass there. So we cross multiply here. Our mass is going to be density times volume. So that means to say we are multiplying this times this, and multiplying this times this, we are going to get density is equal to mass over volume. Let me try to check this. Okay, density is equal to mass over volume. So to we make that the subject of the formula. We're going to wait, we are not looking for mass. Okay, we are not looking for mass, we are looking for the volume. So to make the volume there the subject of the formula, why am I so confused there? To make we have density to be mass over volume, so we cross multiply there. We are going to have density times volume over times or is equal to mass, so we divide by density, so our volume is equal to be mass times density. So it's like 70 divided by 1000, which you are going to have 0.07 cubic meters there. This is our question B. What is our question? Our question last is to estimate the number of cells in your body. It is very simple. Since we already know the number of the volume of a cell and the volume of your body, you can go ahead and find the number of cells in your body to be equal to the volume of the body over the volume of a cell, which is actually the volume of a body we found to 4.9. Okay, we found to be 4.19 times 10 to the power negative 18 there. We divide it by the volume of a cell, which is 0.07. So when you punch this on your calculator, you are going to get the number of cells. Where am I going to write? Running out of space. The number of cells is going to be, I write it here, it's going to be 1.67 times 10 to the power 16 as our number of cells in your body. So what you know about estimation, guys, you need to make a reasonable assumption. That is the only way you can go about any questions on estimations and order of magnitude. Okay, we are almost concluding. And I'm sure maybe this may be the last question. Okay, I wanted to end this topic. We started the wrong time, and we've been moving so slow because you guys, you are still fresh. We can't move at a very high speed. Okay, what have we been given? We have been given the distance. Okay, we have been given to say a fathom now is a unit of length, usually reserved for measuring the depth of water. That is depth. A fathom is approximately 6 feet in length. Take the distance, okay? Take the distance from Earth to Moon to be 250,000 miles. 250 miles. And use the given approximation to find the distance in fathoms, okay? What have we been given? We have been told to say a fathom is approximately 6 feet. That means one fathom is equal to 6 feet. I'm getting this information, guys, from here. Let me point here. A fathom is approximately 6 feet in length. This is where we are getting that information. Okay. Here we are no longer making those assumptions. We are using the information which have been given. So find now, okay, find the distance in fathoms. So the distance already is this. As usual, guys, let's use dimensional analysis to convert this miles into what? Into feet. Okay, here is how you go about it. What you need to know, the conversion factor we're going to use here is 1 mile is equal to 5,280 feet. So to convert our 250,000 miles, we're going to multiply and set miles down so that mile may cancel, and we convert to feet. 5,280 there, feet. Okay, what have we been told about feet? Okay, we have been told to say 6 feet is equal to 1 fathom. Okay, so our aim was to cancel this also feet, and feet will go. So what we are going to remain now is 250,000 there times 5,280. We remain with a fathom there. Then here we are dividing by 6. So our answer now is going to be 2.2 times 10 to the power 8 fathoms. Very simple, guys. Very simple like this. So guys, I think this is the end, as you can see. So I wish you the best as you start. As usual, guys, if you have not yet registered, okay, if you have not yet registered, registration is going at a very cheap price, only 60 kwacha per course. Inbox me at this number. We start together. We help you clear physics, mathematics, and biology. What I can do, I always tell you guys, you can't you can't hang all the 4 courses on top of your head. Okay, it is a burden which you can't carry on your own. What you are going to do, guys, try at least register for 2 or 3 courses. Okay, we help you for 2 or 3 courses. Then this one you'll be trying on your own. This is how you can do best. Those students you see, they do better. Even us, we were being tutored by some. Okay, so go ahead, guys, register. Registration, you inbox me on this number. We'll get back to you as soon as possible. So guys, this is the end of our today's video. In fact, the whole lesson on dimension analysis, measurements in units, and the rest of what we have just talked about. So thank you for watching. See you in the next video. And if it's your first time to the channel, don't forget to subscribe. You like the video. Okay,